when we apply KCL at point A, then we have derived an equation. Okay, that is summation of all the currents, the positive ones and the negative ones. The positive ones comes one side and the negative ones comes another side. So here we conclude that the incoming current in a circuit is equal to the outgoing current of that circuit. So we can express the above conclusion that summation of I, that is the summation of total current, is equal to 0. Okay, thus the above law can be stated as the summation of currents flowing towards any junction in an electric circuit is equal to the sum of currents flowing away from that junction in that circuit. Okay, it simply means that the total current leaving a junction is equal to the total current entering the junction. Okay. Then comes Kirchhoff's voltage law. KVL stands for Kirchhoff's voltage law. Kirchhoff's voltage law means, its definition is, it states that the algebraic sum of all branch voltages around any closed path in a circuit is always 0. That means, according to this law, the algebraic sum of voltage in any closed path of a network is 0. That means, when current passes through a resistor, there is a loss of energy. Okay. Therefore, a voltage drop occurs. When current passed through a resistor, that means when current flowing through a conductor where resistor is there, resistor is a circuit element, then there is a loss of energy. That causes the voltage drop in that circuit. Which means in any element, the current always flows from higher potential to lower potential. This happens. Okay. Then we will determine the voltage sign. Okay. In applying Kirchhoff's voltage law to some specific problems, here we will pay attention to algebraic signs of voltage drop and the EMF. EMF means electromotive force. Okay, otherwise result will come out to be wrong. So first we will learn the sign convention. Okay, the sign of battery EMF is the, here it is shown that the A and B, the first figure, that is A to B, here is the EMF 1 and there is the EMF 2. The rise in voltage and the fall in voltage. The rise in voltage is given as plus C and the fall in voltage is given as minus C. Okay. When current flows from right to left, then EMF is positive, and when the current flows from left to right, then the EMF is negative. Okay. Then the sign of IR drop. When current flows through a circuit, then the fall in voltage is equal to minus IR and the rise in voltage is equal to plus IR. Okay. When current flows from left to right, then that is the IR drop is positive, and when it is from right to left, then it is negative. That is only the sign conversion is there, otherwise the magnitude is same. Okay. Then we will apply the Kirchhoff's voltage law to a circuit, and here is the explanation of that. Okay. Applying KVL for a circuit, what happens we will now see. Okay, the right hand side you will see a circuit A, B, C, D. Okay, here is the loop and the current is and the path of movement either clockwise direction or anti-clockwise direction. Here we will consider only the clockwise direction, and the current also flowing through that circuit in clockwise direction. Okay. Let's assume that the current is flowing in a clockwise direction as shown in the figure. Okay. Here the Vs is the supply voltage, current I is the current flowing through this circuit, R1 is the resistor 1 and R2 is the resistor 2. Okay. Then applying KVL to this circuit using sign convention. Okay, using sign convention we will conclude that Vs minus I1 R1 minus I2 R2 equal to 0. That means Vs is equal to I1 R1 plus I R1 plus I R2, which implies I R1 plus I R2 is equal to Vs. Okay, that is the Kirchhoff's voltage law. Okay, then resistances are connected in series. Then we will study the resistances connected in series, and later we will study the resistances connected in parallel. There are two types of connection. One is the series connection and another one is the parallel connection. Okay. So first we will study about the series connection. Okay. In series connection, the components are connected in one after another manner. That means in end-to-end connection. Okay. Here same current flows through all the components in the circuit, and different voltage exists across each component. That means when two or more resistors are connected end-to-end connection, end-to-end, then they are said to be in series connection, or they are in series connected system. Current in all parts of the circuit is same because there is no other path for the flow of current from higher potential to lower potential of the battery. Okay. The supply voltage is the sum of all individual voltage drops across each resistance. Okay. That's why different voltage exist across each component. Then we will get the summation of supply voltage after adding all the individual voltage drops across each resistance. Okay. Then from the figure shown, three resistances having value R1, R2, R3. This is the representation of the circuit diagram where R1, R2, R3 are connected in series. Okay. And they are connected to the supply voltage V. Okay. Then due to the supply voltage, a current I ampere is flowing through the circuit. Okay. Here is the supply voltage V is there, and the current flows through this circuit, that is I. Okay, due to the current I, V1, V2, V3 are the voltage drops occurs each resistances as per Ohm's law. That is V1 equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Okay, the V1, that is the in resistor 1 that the voltage drop is V1, and in resistor 2 the voltage drop is V2, and in resistor 3 the voltage drop is V3. That means the voltage drops occur in each resistance as per Ohm's law, that is V1 is equal to IR1, V2 is equal to IR2, and V3 is equal to IR3. Now you will understand it better. Okay. Then the supply voltage V is the sum of all individual voltage drops across each resistance. Okay. the supply voltage V is the sum of individual voltage drops across each resistance. Here only three components are present, that is the resistances R1, R2 and R3. This implies the Vs is equal to the total Vt or Vs, the total voltage is equal to V1 plus V2 plus V3. This is the each resistance, individual voltage across each resistance is equal to the supply voltage, that is the total voltage. This is the series connection. Okay.